Hey, it's W5HRO. Well, I have an update for you. I decided to go ahead and do the other mod on this thing that I was planning while I was working on the 1625 because it's actually going to be part of it. You may remember I put this relay in here because I had an afterthought, when I was in San Jose that I wanted to use my SB10 sideband adapter, beside the T368 exciter rack, so I can make this thing work on SSB with that SSB SB10 adapter. And so this thing would have to be put in Class AB bias, so that's what this relay was for. I was going to do a bias switch thing with this knob, AM bias, normal for the Class C. Then when I went to the SB10 adapter, I was going to go here, and the relay would click, and it would switch it to a fixed bias, and I just grid drive it'd still be grid driven, but it would be SSB instead, But that I 86 that idea when I found out about the remember the coax length problem on the T368 exciter, and I had to use that twin lead because the longer you make the piece coax, the more capacitance you're hanging off that thing because it's a high impedance output. So I had to, so I thought trying to hook up that SB10 with the coax, that's just not going to work, so forget it. Although the amount of drive that SB10 would have required in the input, and that piece of coax would have been short to then the output of that adapter would have been fine. It might have worked. It might have worked. The problem is, how was I going to make it work on AM? I had to actually, use the twin lead to make it work for the Class C, just a grid drive coupling, control grid drive coupling. But anyway, to make a long story short, that's all gone. So I started cutting these. I'm removing this. I'm going to remove this relay today. I'm going to take out these two potentiometers. This choke's going to stay because this choke is part of that supply, that fixed bias supply. It's that negative supply. But here's the beauty of this. And this goes back to my original plan on this. And my original plan was I knew I had the T368 exciter, and that's what I was going to use. I decided I looked at the T368 exciter RF deck in this circuit, and I saw that the clamp tube they had in there, which is the military number for the 807, and the 807 is the same thing as the 1625. Remember, I won't go through all that stuff again, but it just has a 12.6 volt filament compared to the others, but it's the same tube. So I had plenty of those in the socket, so I used that. And that was going to be, so if I lost grid drive, I'd clamp. At the same time, I had future ideas because I didn't really plan on maybe just leaving it like that. I was going to use the regulators anyway to do this, right? So I added the regulators because that's really what I wanted, and I want it to where when I modulate, they dim down to where they almost extinguish, and that's perfect. So I thought what I could do with the 1625 eventually, in the end, I could just control this line probably separately, or figure out another way I could put a voltage in here to change that voltage or something. And I just was going to use this tube just to bleed some current off these OD3s, right? And basically what I have here is the screen's being powered from the screen supply. You can see. I mean, from the high voltage supply going to it's just a plate high V supply, but the cold into the mod transformer, and it goes through. And I measured those resistors, and they're 28. What I have is I have three 200K 50 watters in parallel, and I measured across them the other day, and they measured like 28.33K, so 28K is what it is. So, but that gives me, so when the 1625, if it was to completely short to kill the supply, which is what will blow that fuse like it would do when the tube's in there, it would only get like 75 mils or 75 mils of current going through it. But these resistors would be dissipating like about 157 watts, and this bank here gives me 150 watts, so it's only going to be a short time before the fuse blew. So that's what was going on. And I realized I didn't have any bypassing, and I should have, 0.001, I'm going to make that, I'm actually going to put it right on the grid pin of 1625, the ground. I'm just going to put another 0.01, one of those big 0.01s on there. So that'll be better. That may not bypass all the RF, so I'll just put that. But my plan is, instead of doing what I'm doing here and letting it stay connected to the grid, because I have this regulator string that's going to protect the 4-400 screen, but 70 some mils of current is a little bit too high. It may not. So my plan is to make, the 1625, like I was going to do, just bleed some of the current off of this so I can control it. Because that way too, if it's not dimming down enough, I can adjust this to where it's only drawing a certain amount of, just enough current to where these things start dimming down all the way. And that will limit the top current anyway by doing that. And that was sort of my plan. So here's the deal. I remembered somebody posted a circuit years ago for like the Johnson transmitters. This one was for the Ranger. And they're just using an N-channel MOSFET, right? And this is that replaced that 25K dry pot, the Rangers, the Valiants, all the Johnson, even the Viking 1s and 2s had, right? The pot burns up, that 25K pot, 4-watt pot. Over time it burns up, and most of them were trashed. So this was a circuit somebody came up with, to replace that pot, and it'll work. And I thought about it. Well, the control grid on the 1625 needs what, 6 milliamps, and all I have to do instead of using the N channel, I'm just going to change this to a P channel. And even a TO220 package, I was thinking about using a big 3P package, the bigger one, but I don't need amps. The transformer is only milliamps, and I mean, the control grid's going to draw, what, 6 mils? I mean, an amp, I'm just going to use a TO220. I'll find a 1 amp, like a 500 or 600 volt one of these, so it'll actually handle it. Just a P channel, though, so it'll be, negative voltage here instead of positive. And that'll work great. And what I'm going to do is, I'm going to put the transistor right here where this relay is. I'm going to take this L bracket off. I'm going to unhook all this switching stuff for that bias supply. And where I have that 2-position switch that turn the relay off and on, I'm going to put the 1 meg or similar pot. So that's perfect. I'm going to have I'll have an adjustable screen, a screen max limit control to where I can ensure the screen never goes past like 50 milliamps, and I can adjust it to where when I'm modulating, these things dim down all the way to where they just don't extinguish like they should. It's going to be a current bleed. That should work great. The only thing is, like I said, I don't know why. My guess is I think RF was getting into the grid of this tube since I didn't have any RF bypassing on it. And I probably had some RF, the common mode on the chassis was probably, there was probably a lot of RF maybe on ground on chassis, a lot of common mode. And that may have been, because I had that blue wire going to that grid pin on the 1625, and that may have been what happened. It may have had RF, and I didn't have it bypassed. Why, I don't know, but I'm just going to put the 0.001 right there on that pin 4, that socket to ground, right down the ground there. And that'll take care of it. That'll keep the RF off of it. But I don't know why I didn't think about doing that, but there's sort of my mod using like a P channel. And I'm going to also, and I'm going to have that 0.01 there for bypassing. Like you see they have there on their circuit, they have the 0.01s there for bypassing. So I'll do that. I'll have it all. I might put a 0.01 bypass on the FET pin and another one, at the grid of the pin. I'll probably have one in both places, or maybe I'll put like a well, no, I probably should put them close to the pins as possible. But I ordered a heat sink, but I might just be able to lay that just down flat on the chassis. I mean, I was going to make like a little PC board and make it nice and neat, and I still might do it. I don't know. I'm still thinking about it. I ordered a heat sink, but I don't know if it'll mount on top of this board. But this chassis probably be better. Although this chassis gets warm, but these tubes in here and the tubes on top, after this thing's been on a few hours, this gets hot. So maybe I should have its own elevated heat sink that's not connected to chassis. That might not be a bad thing. So I'll have to see though. Well, either I might use this board or I might use another one. I used to have some bigger and better ones of these, but I've used them all. All I have left of these, I think I have one. I think I have one, but it's a big one, and it's too big for in here. So I'll have to. I can probably order something online if I decide to go that route. So I may fire this transmitter up this weekend because it'll work. I just need to leave the 1625 unplugged. I have I don't have anything connected to the plate line on top. It's not even connected to this 500 picofarad cap right now. So I haven't even done that yet. So I could probably use it. It just depends on if I want to just leave this thing out here. I probably won't have all the parts by this weekend because I've just now here recently, as of last night, made the decision to go ahead and do this mod because that way I'll have my screen limit here now right away. I'll just have to play with it and I'll have to, adjust it. And like I said, I'll have to just play around with these resistors because I'm just going to want a window. So I may use a smaller pot. I may use like a 100K pot or a 500K pot with bigger resistors here. I just need to fire maybe a bigger one here and a smaller one there, or, vice versa. I just need to get the voltage window just right for what I need to be able to do on that control grid. But that'll be good because having a solid state circuit will make it smooth. And I'm also going to regulate this supply. This supply right now is not regulated, this negative supply. So I need to regulate that so it doesn't move around. That's the other thing. So I've got to add a regulator transistor. And I haven't even put that in here yet. Because see, what I'll do is I'm going to break this line, and this is going to just connect down to here is where no, wait a minute. Yeah, this is just forget this here. It just moves down here, basically. You know what I mean. This is a separate circuit. It's just that, just forget all this to here, and it's all going to be, this is going to be put in its place there. I'm still going to put the diode, of course. Of course, that has to be there. Maybe not, but I'm going to put it there just for safety. So anyway, but that's where I am on this. So I think I've covered all the bases, and I just wanted to give you a quick update because I see people have been watching my videos, and they're kind of, I guess there is some interest in this ultra modulated setup. So this is something I came up with, like I said, in my head back in the late 80s. And then I got a desk kilowatt, and that thing was clunky, problematic. And I'm like, it's like you had to run it on low power to be legal, which is, how's the saying go? Just turn up the wick and speak softly. So anyway, but no, this is a better setup. So I thought, let me get something where I could it'll make legal limit. And if it ever needed to, it would exceed it, but I don't plan to run it that way, of course. But, it would do it if necessary. This thing, like I said, the way I'm going to run it, it's going to be fully legal. But there's always those times to where, if that plus 3 dB is needed, what I'm saying is this thing will do that extra plus 3 dB. It'll do it. So anyway, so that's the status on this. So I may or may not fire it up this weekend. Like I said, the transmitter works fine. I haven't had this thing on the air in a few weeks, and I thought last weekend the band was in pretty good shape. There's been a lot of activity in the morning, but I think here this week I've noticed the higher bands are dying. 20 meters, 17. Everything's been kind of piss weak. So the band, it's getting towards the end of March, and usually by the end of October, radio season starts, and by the end of March, radio season's over. So that's when it ends, The bands will hang in there off and on all summer, and they're going to hang in there until, April, next month and in part of June. But they're going to, when it gets really hot, when it's 100-some degrees here every day, the high bands it's just a waste of time trying to get on. So there's pretty much, you'll hear maybe 1 or 2 stations on 20 meters every once in a while. In the summertime. Usually DX stations, though. So I guess that's all for now. And my next video, I'll have all my modifications done, and I'll probably do that video cut it off, and then go in there like I did the last time and fire it up and play with it and show you that it works, if it works, you know, knock on chassis, knock on aluminum. So anyway, but for right now, I'll upload this video, and so I just want to let you know where my plan on this and the direction. I decided to finish this up, and I'm glad I had not done the vacuum cap tuning cap mod to this thing yet, because I've been turning this thing over, doing all this work. I would have taken a chance on breaking that thing. So I'm glad that that's going to be the last thing I do. When I get this done, then I'm going to change that cap. I'm going to do the retrofit on this thing and put that vacuum variable. And this thing is going to work on 17 meter AM. That's as high as it's going to go. So that'll be fun. That'll drive those. I can just imagine. I'll probably get on like 17.115 and call CQ. That's where I'll hang out. And that's, oh God, people are probably going to scream bloody murder, high-powered AM on 17. But oh well. Although that antenna I put up for 17, it'll probably melt. It won't handle this thing. So I'm definitely going to have to throw another antenna up for next winter for that band. So that's all for now, 73s. This is W5HRO. And I'm on the tripod again, if you haven't noticed.